All right. Hello, boys and girls. So we are on math, lesson 57. We are talking about rate word problems. All right, so I've written down the definition of rate. This is also in your book, page 365. The rate shows a relationship between two different measurements. Here's an example. The car went 30 miles per hour. If you ever have paid attention to your parents' or your adults' speed, it might say MPH on their car telling you how fast they're going. That means in 1 hour, they will have traveled a distance of 30 miles in their car. So this statement tells us that the car's rate is 30 miles for every hour. We can make a table that shows how many miles the car will travel in 1, 2, 3, and 4 hours. So we'll do that in just a second. Word problems about rates have the same plot as equal group problems. A plan that can help us solve word problems is to make a table. We do this by writing the numbers we know into a table, then we can find the pattern and extend it. Okay, so we're going to make a table with 2 columns. So the first one is the hours, and the second one is the miles. All right, so the first one we traveled 30 miles in 1 hour. So in 2 hours, we double that number and we've gone 60 miles. In 3 hours, we triple that number. So we've gone 90 miles. And then in 4 hours, we travel 30 more miles, and that's 120. If you notice, you look at the digit in the tens place, 3, 6, 9, 12. Those are all multiples of 3 when we count by 3. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. So for each hour, we've gone 30 additional miles, 30 more miles. Okay, so we can find that and extend it. So Liam drove the car 30 miles per hour for 4 hours. How far did Liam drive? This is a rate problem. We don't see the words in each in the rate problem, but there are words that mean in each. The word miles per hour in this problem means miles in each. Per means in each. Okay, so you can make your table. That is a great way to do that. Another way to do it is to solve it with multiplication. So we know that he has gone for 4 hours, and we know he's gone 30 miles. Now that looks kind of silly for multiplication, so I'm going to flip that and put 30 miles on the top for 4 hours. And to get this number, we're going to multiply. 30 times 4 is 120. Now we have to use both of these. So 120 miles in 4 hours, not per hour. That would be way too fast. You can't go 120 miles per hour. But you can travel 120 miles in 4 hours. All right. So Liam drove. That's how far Liam drove. All right, here's another example. Nuru earns $3 a week for helping around the house. Make a table for the rate that shows how much Nuru would earn in 1, 2, and 3 weeks. Then use a formula to find how much money he would earn in 7 weeks. The phrase, $3 a week, means $3 each week. Make a table for the rate with dollars and weeks. The top of the 2 columns, we could extend the table to 7 weeks. Instead, in this situation, we're going to analyze the pattern and see we are multiplying the number times 3. All right, now we know that we can use a multiplication formula to find out how much he earns in 7 weeks. So it tells us he earns $3 every week, right? And we know that he's working for 7 weeks. So our number of groups is our number of weeks. So we have 7 weeks, and then the number in each group is $3 per week, right? So we're going to multiply 7 times 3, and we get $21 in 7 weeks. And what's their name? So we could put N earned $21 in 7 weeks for helping around the house for their chores. All right, we're gonna do lesson practice A together too. Angela drove 55 miles in 1 hour. At that rate, how far can she drive in 6 hours? Write an equation to solve the problem. All right, so we have our group. Our group is 6 hours. And then we have our distance, how many miles she went. She went 55 miles. Now, once again, we don't put the bigger number on the bottom. We need to move that to the top. Because of the commutative property, it does not matter the order. Okay, so we are going to multiply 55 miles times 6 hours. So 5 times 6 is 30. Carry my 3. 6 times 5 is 30 plus 3 more. It's 330 miles. Now, not miles in 1 hour, miles in 6 hours. So A drove 330 miles in 6 hours. All right, we're going to do one more. Barack swims 20 laps every day. How many laps will he swim in 1 week? Make a table to solve the problem now. Before we can figure this out, we have to think about how many days are in a week, right? Oh, it tells us to make a table. So we know that there are 7 days in a week. So on my table, I'm going to make 2 columns. My first column is going to be the days, and my second column is going to be laps. So I'm going to go ahead and label my days 1 through 7. Because I know there are 7 days in a week. And I know one day he did 20 laps. So the next day we're going to do 20 more. So this is our multiples of 2. Then we're going to do 20 more. And then 20 more. So 2, 4, 6, 8. And then it would be 10, 100. And then he does 20 more. Okay, so in 7 days, Barack swims 140 laps. That is a lot of laps, but good for him. All right, so 7 days, he gets in 140 laps of swimming because he does 20 consistently every day. So I hope this helps with rate word problems. All right, goodbye.